Hey, David.
All right. Welcome, Justin, David. Starting to get some folks. All right. I put the link in Slack. Get it over into Discord's already going. I'm going to drop it
Hey,
in.
David. Oh, is there a delay here? Huh.
Hey,
Okay. Hi.
can you hear me?
Yeah, I can hear you.
Justin, David. Oh, wow. Oh, you know what? Maybe someone's watching the YouTube video.
Ooh, yeah.
Oh, no, that's me. That's funny. All right. So 7 o'clock. We'll set the clock going. Hey, how's it
Sorry,
going,
where can I
Justin?
find the Slack channel or the Discord channel?
All right, let me start. We can start putting links in for it now. Let's see. I think it's just set. All right, I'll put it in the Zoom chat.
Thank you.
No problem. And then there's a Discord as well. Is this one still working? That is not still working. Okay. All right, so Izad, let's see, you were first here. What have you been working on with Python lately? You learning?
So I'm
here to teach us.
so I'm relatively new to Python. I have for most of my career I've been working on Java. It's only recently that I've stepped in the Python space, mostly on big data processing with Python. So that's been a little interesting. Yeah.
Nice.
Thank you.
How was the transition been?
It wasn't all that bad. I mean, so while I was in university for my master, which was in a completely different field, there was an opportunity for me to work on a, a buffer overflow issue, and we could choose any system that we could cause a buffer overflow in, and I chose Python as the system that I did that. So it was many years ago that I had to play with Python, create some buffers, and cause a buffer overflow, which was already a CVE. And so I had some familiarity with it, but on a full-fledged project, it was a change in paradigm and wasn't too bad. And I actually liked the language. I mean, I didn't realize how wonderful the language was while I was on Java all these years.
That's awesome. Yeah, I'd imagine going from Java to Python, just with how much more you seem to have to specify things in Java. It's kind of just a little bit easier. I guess you get less performance out of it. But cool. Let's see what else. David or Justin, whichever. Looks like Justin's got his video up, so I feel like he's more ready for a question. What are you working on?
I'm not
David's
using
up.
Python. I'm not using Python that much, but I do use it every now and then, mostly as like scripts for analysis of some very large log files for a C++ project. And other than that, it's like test scripts. That's most of what I use Python for. I use it for a couple other stuff, but that's mostly it.
Nice. It sounded like David was about to answer.
Yeah, my video is disabled on my work computer, so fortunately you can't see my beard, my COVID beard. But yeah, I've been working mostly in the Jupyter framework, trying to do like HMC Monte Carlo analysis of Bayesian posterior distributions, fitting to experimental data. So that's been new. That's been consuming my time for the past month or so, and mostly working with like PyMC3 and Stan PyStan and so on and so forth. So it's been a lot
Have
of
you
fun.
tried MC, David? EMCEE. It's a lot easier to get started on that, but if you're already,
I started on that, but it didn't have all the functionality I needed.
Gotcha.
So it was just easier to work in a well-defined model space where it's like PyMC3 and PyStan are built as a Bayesian in a Bayesian framework. So it's all it's very easy to pull out like the log posterior distribution and so on and so forth.
Yeah, that's true. Yeah, MC is lower level stuff. You've got to define your likelihood and posterior for it to sample over. That's true.
Yeah, and I'm not fitting these massive like neural network models or anything like that. I'm mostly small data experimental analysis kind of stuff. So, I mean, eventually I'll move into like the PyTorch space, and I will get into that. But that's in the future. So, got to finish this paper first.
Gotcha.
Good luck with that. All right, we got some others. Jagjit, Claire, Tessa, and Elbera Fart. Hey now, welcome. Oh, whoa, Tessa was stealth there for a second.
Hello.
All right, what are we all working on with Python? You learning it?
Sorry.
Yeah, what are you working on with Python? You learning?
Okay.
You here to teach us?
No. I have 15 years experience in home country as COBOL maintenance area in bank system. But I moved to Canada. That's time I am interested Python. Maybe I am change my working area. Yeah, I'm studying Python recently.
Nice. Yeah, I made the switch myself just a few years ago. I was always adjacent to software development, and I had a chance to go back to school, and Python was one of the courses that came up. And next thing you know, I'm actually using it. So cool. Welcome to the Python community. What are you working on, Jagjit?
I mean, right now I'm not working directly on Python, but I work in biotech, so I've kind of used it for scripts. There's a lot of export of data kind of thing to get it into documentation in the right format, and then just make sure that it is the right stuff for production, like, and then vice versa, like if you're testing stuff in a QA system and then want to make sure that it's correct in the documentation, kind of being able to go back and forth. And I have a lot of development experience, and Python just has these super easy libraries to make it. I mean, it's the easiest coding language I've ever used. So, in my humble opinion. So just being able to dive in and crank through Excel files or even or JSON, XML, that kind of stuff is all super easy. So
Cool.
kind of
Automate the boring stuff.
So yeah. I was using that site a bunch, so to make
great.
my way through. So
All right, we got Dan and Rob. Welcome. What have you been doing in the Python world, Claire?
Oh,
you're muted.
It looks like you're,
I'm pretty new to Python, actually. I just started with it like within the last couple months. I've been coding for a long time and used to do a lot of work with SQL and big relational databases. So I'm having fun learning Python and using some of the tools to make data analysis easier. So I'm just I'm learning right now. Got a couple little projects, but nothing exciting.
Hey, Robert, how's it going?
Hey, good.
Today.
Yeah, I can change back to being my old self.
Hey, I mean, time's only going in one direction, sir. Don't try to edit the past. All right, working on these days?
Hey, good evening, guys.
Good.
Yeah, this is probably my first time here. I had been having some issues with the connectivity, but yeah, like
coming through loud and clear.
Yeah, now it's good. Probably.
Yeah, you sound fine. Mm-hmm.
Okay. I'm having hearing issues, probably like maybe there's echo, but never mind. It's good to hear now. So probably this is my first time with SacPy. I am based out of like California, Rancho Cordova, and I've been working for like a solar company for last 3 years. I've been using Python mostly. So most of like I'm a newbie on the Python side. Had prior C and C++ experience, and then some had been like trying to work with this, like looking for like really good data sets on COVID-19 stats, and I think like Tanim's description actually really helped out a lot, and that intrigued me to actually join and like see what you guys had been working on. We're happy to like go through that and then like understand a little bit. Yeah.
Cool. All right. Welcome, Michael. All right. It's 7:12 Pacific. I think that's about enough time to collect some people. I'm sure maybe a few will stagger in. A couple of you may let yourself out, but I think it's about time we get going. So let me get this thing started. All right. Do the virtual background thing. That one's always fun. And let's go. All right, so welcome to another round of SacPy. Let's get this thing going. All right, it's March 4th. Did everyone March 4th today? Take at least one step forward. Man, March 2020, what a month that was. Can't believe it's March again already.
March never stopped.
I think I've cut my hair like the last 6 times. Just buzz it. Forget it. Just gave up.
All that started on the Ides of March, didn't it?
Oh
yeah. I think the quarantine came down, as in go home, guys. Yeah, Ides of March.
So beware the Ides of March.
Well, none of us got stabbed, so you know, there's that.
Yeah. Hey, that's a good day right there. All right. So SacPy was started by Josh Miller a number of years back. Hail our glorious leader, who's now out in Tennessee, I think. So I don't know. He pops in from time to time. I don't think he's with us tonight. All right, we are in a number of channels. Can everyone see them? I'm going to post them again in the chat. I don't know how good those QR codes are these days. I'm pretty sure the SacTech one is fine, but I think that Discord has expired. But oh my, I just posted the same thing twice. That's brilliant. All right, sorry guys. Snafu. Could someone copy the links from earlier? Mine's not letting you copy it. Anyway, we're in Slack with a group called SacTech. We got a channel in there. We also have a Discord. I posted it earlier. Can anyone copy paste that? Anyway, we're also in a number of other outlets on social media. We've got a Twitter, tweet sometimes. Maybe we should do a SacPy one day where we use the Twitter API and hook up the SacPy Twitter, get it tweeting but for itself or something. We also have a subreddit, which awesomely, I think, opened us up to some Zoom bombing in the past. So I've been a little gun shy on that one. If anyone wants to jump in and help on that, by all means, let me know. We also have a Facebook group and a page. Post stuff about upcoming events. Could be more if anyone wants to help with any of those, let me know. All right. All right. This time of the event. Oh, thanks, Jagjeet. And do you mind throwing the Slack one in the chat as well? Jagjeet so kindly grabbed those links for me and threw them in there.
Oh, right, Zoom, yeah. It's you only see the chat after you've joined. That's right. I forgot.
Yeah, exactly. I was like, oh no. All right, guys. If you've got if you've got something funny to like put on your head or hold in your hands, I like to do like a group shot. If you don't want to be in it, just like keep your camera off. But I like to put a little like Brady Bunch thing together after each of them. Do some real quick screenshots. All right, 1, 2, 3. Oh, nice blanket there. Oh, Robert's asleep. No way. Oh, Dan is an orb again. Nice. Tessa looks focused. All right. Thanks, guys. Thank you for participating in yet another round of SacPy Brady Bunch. All right. So first up for this evening, Tanim Islam has returned to update us on his COVID data science project.
Yeah.
It's got some exciting new updates. So without further ado, I will hand it off to Tanim.
All right, I'll start the share. Oh, it said disabled.
To make sure he can do it, and you should have the option now. Go for it.
Share. Okay. I got to go through this slowly so I don't break stuff because I've got about 12 windows, just in this workspace. All right. Here we go. All right. I'm going to start on the presentation. So the title, let's see if I can hide that, or let me take the chat out of there. So the idea is this is a hobby project I've been working on for almost a year now, or it's coming on to a year. And I call it COVID-19 Stats, Experiences Visualizing and Deploying Data from the New York Times COVID-19 Database. And I've got to give a shout out to the New York Times because they've done a really good job, standardizing and normalizing the data of COVID-19 cumulative cases and deaths of every county in the US, like in every state and US territory. And so that's sort of what I build all this data visualization and analysis upon. And I guess for funding agencies, here's a little subtitle, an example that shows where the US faces challenges. And I'll do it. So, yep, I've spent about a year doing this. And there's quite a bit of code in there. There's like 1,000-ish lines, although it's divided up into like a few classes of functions. But instead of going into a deep dive in the code, and of course, like by default, I figure I'll just demonstrate the functionality with a beginning to end flow, like start simple and get sort of kind of complicated, or like have sort of an end state of something that updates daily. And my style of lecture is feel free to ask lots of questions, interrupt me, whenever something pops into your head, and we'll just do sort of a meander, kind of a random walk through the things I want to talk about. So basically, it's sort of what's this thing for? Is that it can make PNG and PDF figures and MP4 movies of right now cumulative COVID-19 cases and deaths out of the box, as in through the command line tools, the metropolitan statistical areas. And I think it uses the US Census database, so there's about 300 or so of them defined. Really only the top 50 matter. Sorry, people smaller than, I guess, Rochester, or MSA smaller than Rochester. States or US territories. Right now, I've just got visualizations of the US states, but I guess you could put Puerto Rico in there, and the CONUS, or continental US as a whole. and bunches of links. And actually, I'll take a little digression. All this stuff actually is continuously updated and lives in a bunch of places. So there's 2 public Google Colab Jupyter notebooks that demonstrate the latest running output. And let me see if I can put the links into the Discord chat. So, oh, sorry, not Discord, but the Zoom chat. And let's see if it'll let me do that. There we go, chat. So this is MSAs here. So you can, go on your own computer, just watch this in parallel. And states and the continental US are here. So feel free to look at those actual MP4 animation movies, which should be publicly available to everybody. Just to see while I'm talking, if you want to see exactly what I'm doing. All right, let's go back here.
And those are the links that are on the meetup, right, Tanim?
Yeah, they're on the meetup. Yep, they're here in the Zoom chat. They're actually in the Slack channel, SacPy, and in the Discord SacPy. Yes, 4 places. There's a GitHub repository, which that's actually, if you guys want to go into a deeper dive of how I implement some of this functionality, I'll go to the GitHub repository and go to the specific bits of code there. And there's a read the doc style Sphinx documentation associated with this. So I've tried to do a good, quote unquote, good job documenting, the code as well as the command line tools. Like, okay, what do all the flags mean and what sort of output does it produce? And I'll go through one example by default, in this presentation. And the presentation itself, this thing that you're seeing right now, also lives on GitHub. And here's its, address. There's a README at the top level that tells you what's in there and where everything lives. And there are subsequent sub-READMEs in each demonstration folder that demonstrates, I think, 3 command line or 4 command line tools on either MSAs, which is the example is Richmond, Virginia, a state, which is Virginia, and the continental US. And a 4th one that says, here's an actual supercomputing, job scheduling script, safely anonymized and sanitized, that does the update and upload of daily new COVID-19 data sets. All right. So all this stuff. Okay, I think I sort of covered all this. So updating it is just a simple command. It's right now about a 45 megabyte database, CSV file that it reads from, the thing that updates every day. So if you're doing it from scratch, it takes at most 20 seconds. But if you increment it, daily, like, okay, you already have something that's maybe a day or a few days out of date, it takes at most 5 to 10 seconds to do. And all these things are just links there. And I guess I could go through here and show you what I mean by the Sphinx documentation. This is just the documentation page here. And there are a bunch of links in both the Keynote version, PowerPoint, and PDF version of this presentation. So if you want to take a look at it, just go nuts and click away. All right. Going back. So looks kind of like an eye chart, but it's just, command line tool. It's got the main one, if you want to visualize the continental US or the metropolitan statistical areas, there's this thing that has a pretty big name, COVID-19 Create Movie or Summary. And if you want to summarize the metro areas, it's just telling you the help screen. And here's just a demonstration of what it looks like. Here's the thing it will spit out. In this case, I'm just showing, run it. It'll take maybe, I don't know, probably 30 seconds to do, in this case, the top 20 metropolitan statistical areas. And by top, it's ordered from, biggest population to the smallest. And these are sort of the tables it has here. Population, the date of the first incident, the case, the total number of days for which there's a record. And this data set is pretty consistent. If you just add this date to that day, they'll point to really this day here. Or at least, I think I did a check a while back to validate for myself. Yes, this plus this equals that for every single row here. The total cumulative number of cases, deaths, as well as something useful, the maximum number of total cases in the county, and the county name for which it's a maximum. So this is, if you want to create now create a summary of a region, in this case an MSA or CONUS. It's this, is there a way to do a pointer in Keynote? I don't know if there is. I wish I could show you. So you just look at this S here, and what it'll show you, it'll give you these 7 things. 2 PNG and a PDF of, in this case, the cumulative number of cases for the last incident date, cumulative number of deaths for the last incident date, a trend plot, a trend line, logarithmic of, from beginning to end of cases and deaths. And what I'm not showing here is this serialized Python data file, a pickle.gz, that contains the serialized incident data from which these figures are created. And I can, if people want to, I can go into that just a little later, sort of towards the end. And now here's the stuff that, uses up a lot of disk space. Let's just show this here. Now, the thing it does, and I sort of alluded to this in the previous presentation I gave, which was last month, which is you basically, okay, you've got a bunch of PNG images and create a movie from it. That's really, at a low level, what this coding does to create these movies. And here, I think, yep, cumulative cases running from smallest, well, I guess, 5 frames a second. So that's what, 70 seconds?
Sounds about right.
Yeah. So how's your week's been? Good? Not so good?
Yeah, pretty good. Thursday.
And it's all using matplotlib for, the actually creating the images, and auto crop to remove all the white space, and auto crop with what is it? Making sure if the figure's width and height aren't multiples of 2, then it just does a change by 1 pixel to create, PNG files that are multiples of 2, so that you can join them together into an MP4 file. Let's do the one with the deaths. And I chose Richmond, Virginia, since that's where I grew up, and my parents are there, and yeah, just going through it. And it takes, I think it takes about 3 minutes to generate this movie file. And so it helps to parallelize it, batch it off to, different processes. So if you've got to do 26 regions and 3 separate movies each, if you try to do it serially, you might be waiting all day. But if you are a little bit smart about it, you can get it done in about 45 minutes. And this is the thing. Okay, I guess it's just getting lighter colored, just a little worse. And you see there's a tick mark going there. And this one is a thing that I tend to show a lot. And that's actually in the Jupyter notebooks. Is this really useful plot that shows both of them together, a quad plot? You know, summary data with a counter, basically the ball of case and deaths as it's going along. And, you know, upper right, deaths, lower right, cases.
So what you mentioned early on that there were some data that were being like omitted. What does it take to get to what would feel like, you know, complete capture of data? Like what's missing right now?
Well, what's missing? It's, I think, really extra functionality. What I want to do is enhance it so that it also has a 7-day rolling average. So then it's a lot easier to see, okay, there are these counties that flare up and then die down as sort of, you know, new rates of incidence of COVID-19. Like, okay, oh, wow, there's a really big spike here. Then it's harder to see with a cumulative plot, but it tends to become a lot more transparent with a, you know, a rolling average, 7-day rolling average plot. And here's just a link to it, but you guys can visit it yourself. And here's basically what I'm trying to say here is there are, I think, 3 demonstration directories, 4 demonstrations per directory. So, you know, 12 of these things. So, you know, the first part says, look in the demo Richmond directory, look at the README HTML file, and look at the section called summary to see, you know, basically demonstrating how to generate that data as well as the figures, like either the PNG and PDFs or the movie files for the bottom 3. So yeah, the hashtag means section name. Quad is just basically that four layer thing. And I'll just go do a little digression here to demonstrate just one bit of that functionality. So I think I'm sharing this screen here, right? This should be showing.
You can see your terminal.
You guys should see something that says Richmond, right? And then the pound sign. Does everybody see it okay?
Can you zoom the text in a little?
Sure. Yeah. How about now? Does it look a little better? Okay.
A little better.
And since I don't like to type a lot, if I have to, let's just copy paste it. And I'm going to do time to say, okay, cross fingers, hopefully it'll work. It should work. But you know, it takes about 30 seconds to do because Claire, this might be in your wheelhouse. Right now, it's not so lazy initialization. So it actually loads in all the GIS data before, you know, doing the operation. So there's always some sort of stuff that happens. As you can see, 35 seconds. And here is the, lo and behold, it generated that stuff. And I'm going to go to the website again. Here's sort of a dirty little secret or a neat little trick. Is how many of you have used Jupyter notebooks before? So the nice thing about them is they are sort of a poor man's way of doing, they're a poor man's web server, which means that you can look at HTML code, and let me just delete that stuff here. Let's see. So this is the Richmond one. This is the README I was talking about. lo and behold, there's just HTML. And it can, if your HTML isn't very complicated, no JavaScript, I think the CSS, either no CSS or, fully qualified address to the CSS files. It won't look great. It'll look like, early 2000s HTML, but, it will. It'll render properly. And let me go. So, it generated 7 files, and I'm just going to show you exactly what it did. So you can see, okay, see? Generates that fine. There's, of course, yep, nice little error message there. And let's see if it can show you the movies. Probably not because of security issues. But lo and behold, it does. It's a nice way of rendering HTML. You don't have to, load up some. You don't have to have sort of an endpoint that's publicly accessible, and set up the infrastructure that way. This is just a sort of a backdoor method of showing you HTML. And this is the final thing was this serialized file, which I've highlighted here. That's the pickled version of the incident data that that this code generates, or that demonstration generates. And I will show one thing, I think, and I think it's useful to see. Let's go to, yep, this is the read the docs page. Let's just see 2 things, I should say. Let's see what the continental US is going to show us. Sort of a nice for all of us. Logarithmic plot on the left. And it's kind of harder to see here, but stuff went really bad really quickly in the New York City metro area. And then it started going progressively badly elsewhere. And, this is the latest New York Times database information. In the continental US recorded 28.5 million COVID-19 cases and almost 513K COVID-19 deaths. As you can see, it's sort of leveled off a bit here, but it's a logarithmic plot, so it doesn't look quite as bad as it is. That's why something like the 7-day rolling average with a linear scale would be a really useful, visualization thing to identify hotspots. What I showed you guys actually last month was, something from, the beginning of February, right? Something like February 3rd. This data set is currently updated every day. So the latest it'll have so far is March 3rd, just the day before. So you go back and let's see. Let's go through here. See what else.
So you're using New York Times data. Are there any other sources of data that you're looking at potentially?
No. Right now, I don't want to, spend too much time trying to do that. I thought, okay, what can I learn about? What can I visualize? There's a WHO, World Health Organization, database. I haven't really looked at that. That especially has data not only just in the U.S. but around the world.
Right.
But that would involve learning more stuff. I was sort of spoiled. The New York Times database is very, very easy to follow. It's just a CSV file that says basically, here's a county name, here's its county code, here's the cumulative number, the date, like 2020 0305, right? And here's the number of cases cumulatively and the number of deaths cumulatively. And so it's basically turned that into a pandas data frame and then take subsets of it and do some more other stuff to it. attach it to GIS, Geographical and Informational System databases to create those figures, those movies and figures that I've shown you.
Maps. Yeah.
Does the New York Times talk about their process for putting it into that format?
I think so. There's like a bunch of articles, especially at the beginning, I think around February and March, where they, go into details. There's also, the New York Times also has, on the front page, various figures as well as animations of like the vaccination rate or stuff like that, by state. And that's based off, more data that was filled into the New York Times database. There's actually, vaccination data set right now that I don't use right now. I'm just going back from a year ago, cumulative cases and deaths. So here, here's the thing. Here's the synthesizing all that stuff, but doing it 26 times, these 26 regions here. And right now, as of, 3 hours ago, it's about 1,017 megabytes of data per day that are created and deployed to this, URL here. And if you know me for any amount of time, you know that I don't like to use my own resources as much as possible. So details of, availability of the data, as well as, okay, what sort of bandwidth quota do I have? Not my problem. It's GitHub's problem. Well, so far. They haven't told me anything in the meantime. It also updates the COVID-19 stats GitHub repo, README with the latest data. And I know this might make some of you a bit dizzy, but I want to go back to what I'm showing here. You see sort of this table here, right? This is the thing that is also updated, daily. And so it says here, COVID-19 stats for the 50 metros as of 33 March 2021. Sometime a little after midnight, probably around 1:30, this web page will be updated to say as of 4 March 2021. And of course, the numbers, days, these columns here will change accordingly. This stuff also changes accordingly. In fact, I should point out, you see the URL here? It's all pointing to stuff, hosted on GitHub through GitHub pages, which is a neat way to get a lot of data, or a medium-sized amount of data, to be visible to lots of people without having to worry about, is Comcast going to give me a hard time, that sort of thing. Okay, let me go back. And if you want to, yep. The thing is also, it takes about 45 minutes from, okay, start the process to everything fully deployed and updated, both in this, this sort of bin of data and the GitHub repos README. Beginning to end 45 minutes. And if you go through, all this stuff, all these resources that I have for describing, the COVID-19 stats as well as the data, it all points to stuff like PNG files, PDFs, JSON files, and MP4 files within this URL. And there are 5 steps to it. Update the database. This is the part that really takes a while. Summary of the 26 regions on 9 nodes, which is, a command line tool in the Sphinx documentation. Then it does the animated GIF of 14 regions, because I'll just say it right here. GitHub is pretty good. I'm actually very happy that they let me abuse its service so frequently. But they do have a limit on you know, the README. That's the front page of your repo. It's limited if you point to an external URL. The figures and animated GIFs qualify as one, are limited to 5 megabytes or less in size. And so I have to do stuff to create those animated GIFs. I have to basically play some games. And oop, what just happened there? Yes. This is pointing to, you know, the previous talk that I gave, as well as a slight description of a repo that's used by a lot of the stuff called NPR stuff. And this MP40 GIF is that that method that, you know, takes in, here's an MP4 file and convert it to an animated GIF. And deploy those updates, you know, basically it's basically git push. And then I guess update the README with the newest data of, you know, COVID-19 stats. Any questions so far? Anything you want me to go into a little bit more? Say, Woody, you had some questions yesterday, or maybe I answered them.
Yeah. Well, no, I was going to ask him again today. Well, I had one question about data, but I guess it sounded like you weren't as focused on capturing more data. But I was wondering if you came across testing numbers. Like, did anyone have numbers for how many times people had tested?
Actually, let's see if I can take a look at that. I'm going to go into the repo itself. Let's see if I can. Let's see if, it's a lot of crap. Okay. So this stuff, hopefully this lives here. And you know, I've never looked at the testing here, but this is a Git submodule in the repo itself. That is the actual COVID-19 database, which is, you know, deployed as a Git repo. New York Times COVID-19 data. And you know what? I don't know what's in all this stuff. U.S. counties recent, where there's live. Let me take a look. Uh-oh. Sorry about that. Or maybe this is a little too big. Let me go into here. I'm going to go into more of a deep dive. Have any of you heard of a thing called TMUX? It's yeah, it's basically a way of saying, you know, I don't want to have a bunch of windows everywhere. I just want to have one window that I can traverse through so that there are a bunch of different sessions in it. And let's see if I can, that's what I find really useful for organizing my work. So let's see, what was it? US dot, use that CSV? No, that looks like basically the cases and deaths. You can see, you know, date, state, count, you know, county, state, or yeah, basically, this is what's called a FIPS code, federal something, something, something. I'm not a U.S. Census guy. But there are a bunch of links both in my presentation and the Sphinx documentation that say, point to the Wikipedia article of what it means. It's the U.S. Census. Let's see if grep our, what was this, vaccine, right? Let's see if there's anything there. Huh. You know, it might be in some other repo. But to be honest, the thing I really look at is uscounties.csv, which contains the raw, you know, normalized, but constantly updated, you know, tally of cumulative cases and deaths in the of every county in every U.S. state or territory. There's something called mask use. I don't know. maybe this is, I don't know. I really have no idea. I've never looked at it. So you're probably looking at it the same time as I am. So I don't see anything here that says, okay, here's the vaccine. Let's see if get fetch VA. I don't think there's any other branches that might contain other data that I think. Huh. Yeah, I guess vaccination is probably, might be in some other repo. I think this just really has, it's really focused on COVID-19 cases and deaths in the United
but
States.
cases are the result of testing, right?
Well, I think there's, hospital data, and the states gather that data. They count, okay, this person died of COVID-19, throw them in the pile, or they got COVID-19, so throw them in the pile too. But you bring up an interesting point, is this is a constantly updating database. So it's not as if, let's say 2 weeks ago, there's a best estimate of the record of, cumulative cases and deaths from Sacramento County, in October, 5th October 2020, right? Now, let's go current. Let's go now, or yesterday. The thing is, that best estimate of cases and deaths, or best record of cases and deaths of the same county, like Sacramento County, October 5th, can change due to better data, more information being gathered. So it's not as if you could say, okay, this is the record of in the past 3, 4, 5 months ago, and it will always stay fixed. It does change actually based on sort of more information that the counties, states, and the New York Times collects.
Right. Something I'm kind of curious about is, how could you apply these techniques for other applications, right? This is a fun thing to talk about.
Mm-hmm.
But what other applications are there for these same methodologies?
Of visualizing the data?
Yeah, data visualization.
I mean, I know I'm being kind of flippant about the work I'm doing. It was an interesting project and an interesting way of, getting the data out for me. I know just off the top of my head, you could try something for Canada, see what that looks like. You could see how Europe's vaccination efforts are going. What I'm going to do, actually, I'll try to do in the next few weeks, is to also visualize the rates too. I'll start with the semi-heroic calculation. I say heroic because it takes about 10, 15 minutes to do. A 7-day rolling average MP4 file of average new cases of COVID-19 and new deaths due to COVID-19 of the continental US, just to see what that looks like. I mean, you bring up an interesting point.
Yeah.
The business
so for example,
logic.
TMUX, everybody uses that for system administration, right? That has broad application. So I'm wondering, what are some of the other applications of this data visualization, and also, how would you go about using it for, I don't know, say, looking at server uptime or something like that?
There's a bunch of bespoke, matplotlib code in there. I can show you exactly what some of it looks like if you're interested in taking a look at it. Maybe it'll give you a better idea. There was something else I wanted to talk about. Oh, it slipped my mind exactly. But maybe I'll see something like this. But okay, are you seeing this basically 795 lines? It's basically a lot of crap in there. But I've tried to, subdivide it into common lower level to higher level functionalities. This is basically, these two methods, for instance, are the thing that says, overlay geographic data. This stuff says, okay, make sure I have the right, bounding boxes for that data, or try to find the center and bounding boxes of it. Okay, now that I have the counties, let's see if you can display it. And basically display it. And then finally, on top of all that stuff, basically calling all this crap, is actually, create a PNG figure of, cases and deaths associated, of that given date from beginning of this geographical region, either an MSA, a state, continental US. Technically speaking, since this is an API, you can define your geographical region fairly arbitrarily. You can say, maybe you want to look around the four corners. I forget which state has that. Is it New Mexico, Utah, Arizona, Colorado, right? Technically speaking, you can hack at this API to, have a visualization around there. And then finally, and this brings up to that point, what is this? Let me look for this. Is the, okay, here's a bunch of PNG files that are created from, those lower level functionalities, and create a movie out of that. And there is an interesting thing, and I found it very useful for data management. These are MP4 files. MP4 files have, a bunch of nice APIs, both in Python and elsewhere, for pushing metadata into them. Like, okay, title, album, some description, song name, stuff like that. And this is, functionality that I found useful to put in there, so that now I can have external methods that are relatively stateless. That is, you don't have to carry state with them. It can extract the state from the data files in there. And you bring up a good point. I know I'm sort of, meandering and hopping, but I figure let's discuss some of this. So
that looks really interesting. The metadata tagging, the library. What library is that?
It's in Python. It's called mutagen.
Mutagen.
Python mutagen. Google search. It's going to be the top one. And I'm just doing a quick and dirty, just look at the tags. It's a tool called MP4 Info that does that. I figure I'll toot my own horn and say the artist is Tanim Islam, since I'm the one who coded it up.
All right. Well, does anyone else have any questions for Tanim about this awesome project?
Actually, I have a little more stuff if you guys want to take a look at it. I know.
Oh, yeah, sure. But wait, there's more.
But wait, there is more. There's, of course, I say flesh out and complete the API. And so let me show you in a little more detail what I mean by the API. Let's just take a look at it. With Sphinx, you can create, without a huge amount of effort, pretty snazzy bits of documentation. And if you see this thing, you can have code refer to other code, like it's got this internal link here. Or rather, there are doc strings in the Python code that I have, that if you run it through Sphinx, it'll be able to actually properly document that code. You see this thing with arrows here, this arrow icon. This is an actual file that you can download that contains, for instance, serialized geographic GIS data that you can load in your Jupyter notebook and see what's there. there is, I kind of do want to show this thing. Oh, not just GIS. In doc strings, in your doc strings, documented Python code, you can actually also refer to external URLs, which can be images. And this is, for instance, one functionality that I use to say, okay, what is the bounding box of, of this collection of geographic units, these FIPS code counties? This might look familiar to a lot of you, right? Can anybody tell me what you guys are seeing here?
It's Sacramento and what, Yolo County on the
Yep.
left?
This is the Sacramento metropolitan statistical area. And so, in pink or, sort of low alpha red is the bounding box of each of the counties. And of course, you take the min-max of all of them to get that green thing, the bounding box of the whole geographical region.
So is this GIS library a standard Python library, or is this something that you developed?
Sort of hacked it together because there's actually, you bring up a good point. There's SHP files. I do use one GIS library called SHP Reader that can read in at a high level shape files. And to be honest, the last time I looked at shape files, like as in query, like opened it up in a text editor, was probably mid-April, beginning of May 2020. So, but the data, let me hop around again, let me go there. Let's go to the resources directory. Yeah, I guess it's in here. Like this is the census data, 2018 census data of the US, and I guess it's binary data. I guess I couldn't open it up, in the console, at least easily. But there's a shapefile reader, which I guess shapefiles have a fairly simple schema or straightforward schema, which is, okay, here's the FIPS code, at least this shape data, the FIPS code of the county, the bounding box of it, minimum lat long, maximum lat long, and the list of boundaries that make up that county. Because the simplest kind of county is it's just one single, geographic region. So that's a list of size 1, defining the boundary. But it can have, multiple sizes associated with it. And there are some like that. Let's hop again. I figure let me just segue to what I wanted to show before, or show at the end, which is, I mentioned, getting the rolling average, the 7-day rolling average. Let's see if I can get that. There's an actual, Jupyter notebook in the testing subdirectory of the repo, which I guess you guys can hack at. And here's a bit of functionality. Please work. Yep, there it is. See, things that look like 36103 here. Those are, I guess, a part of Long Island, Eastern Long Island, consisting of multiple, separated geographic regions in that county. And I don't know if any of you are New Yorkers, to the bone. I'm not sure what those other county names are. I think I sort of kind of know, okay, there's Staten Island, there is Queens, Manhattan, and the Bronx are there, and probably Brooklyn somewhere in there too.
Staten to the left.
Yeah. And let me go through one thing. I haven't put in the rolling, average, but I can extract that from the database, from the data that currently exists. Now, I don't want to, waste 10 minutes of the time to generate the data. Let's just load it from serialized data that's already in that directory. This is the incident data, that pickle.gz that, if you recall in the demonstration directory, this is the kind of data that, contains incident data for that geographic region. And this is for the CONUS. In the demonstration directory for Richmond, it's for Richmond, Virginia. But okay, I'll just type away cumul cases and cumul deaths. I'll just convert it into a NumPy array from the pandas data frame, which is in this, in this key in that, data set, which is a dictionary. Let's just get the datas in there. And, if you guys want to, you can even just, download this repo, clone the repo, and, introspect to your heart's content. And now let's show it. This is the case rate. You see it here? And this is why 7 days is nice. In blue is the smooth 7-day one. You see the 1-day average reflects just spikes in reporting, which is about of order 2 days. That is okay. There's a lull in the amount of data that's been reported in, and hence or there's a big backlog that's filled. Hence the spikes that you see here. To get sort of a more realistic reflecting data set that reflects the actual trends of new cases. That's why the New York Times refers to 7 or 14-day rolling averages. And this is for the cases. Oops. Oh, sorry. This is the cases. Sorry. And you see it here. These spikes that it sort of smooths out. It looks like we're doing better. Not great. The scale here is 10 to the 5th. But, I guess we're less than 100,000 cases per day, rolling average. So I guess that's a win. Or, similarly, the deaths, which is not great, but better than it was, I guess 50, 60 days ago when it was really, really bad. But similarly, something like that, for visualization would be really useful to have. And last thoughts. I guess, Claire, if you're still here, the initialization that's done here is really not very lazy. That is, it basically, whenever I want to do anything, I have to load the whole data set, all the geographical data, all the, current, giant, millstone of cases and deaths before doing anything at all. It might be useful if people want to hack at it, to have some kind of persistent but constantly updated data store that lives on a server somewhere that then I or others can query to just quickly only get the data that I need. So it won't be sort of an initialization penalty that I would have to do. If I have these single initialization penalty, but do 30 different operations, it's not so bad. But if I've got to basically ramp something up and do only one thing and then kill it, then it becomes impractical. Here's sort of the not so lazy way of how it's initialized. There's a singleton, class that contains both the current counts as well as the GIS data. It's basically the engine.gis module is the thing that populates all this data, and then there's basically these methods to get at the data, to visualize it, that really call this, or introspect this instantiation, singleton instantiation of this class to get at the data. And I think that's probably a good place to stop. There's links to the repo. There's even there's links to the Sphinx documentation. There's a bunch of Jupyter notebooks in there that in the course of creating the files, the images to document the code, there are fairly good demonstrations of the overall SDK's functionality in there too. And any of you have any of you heard of a chat solution called Gitter? Gitter. It's sort of like Slack, but hosted by GitHub for doing sort of code chats and things like that. These two projects, COVID-19 Stats has a Gitter room, which I've never used, and the NPR stuff, the thing that contains the lower level functionalities to create the images and the movies, also has its own Gitter chat room. And I guess with that, anything else you want me to talk about? I know I've probably used up sort of your bit of time too, Woody.
That's all right. We'll go till the end. Any other questions for Tanim?
Hey, Tanim, how easy would it be? I guess I'm just curious how hard coded things are to translate some of the same code that you've been using for making your videos to doing like a per head calculations rather than just the flat numbers.
It's fairly straightforward. Like by per head, what do you mean by that exactly?
I guess relative to probably county population, since most of
yeah, like per capita rates.
Yeah, like maybe
straightforward stuff.
Like per capita or total.
Yeah, it's straightforward to do. It's a little deep dive into the code, but once you know sort of where the hooks are, the important point is that there's this object called inc data underscore data, and it takes stuff from there. Actually, yeah, I'll just describe it here. INC data contains basically right now, cases and deaths per county, right? But the population data is also located in the GIS database. That's how you get, say, the populations of those metro areas. It's just a sum of the estimated, 2019 census estimated population of the county, of each county in that geographical region. So you can just do everything, those numbers divided by the population to get at the per capita, incidence rate, cumulative as well as new incidence rate.
How about customizable time windows rather than doing from like date 0 to now? Like,
yep.
Zoom in.
Good, very good question. I'm going to go into a little bit of code here. Let's see, this is called from beginning, but that just takes from 0 to X. But it's calling methods that look like, you see this argument here. Let me show, do you see like this? I'm gonna make it a little bigger. This, create plots days from beginning. You don't necessarily have to give it, 0 to the end. You can give it a set of days, that starts from day 30 to day 60. Now there's probably going to need to be some utility functionality that says, okay, convert this, convert actually a day window, beginning to end, to, the actual days from beginning that you want. But you could, it's not terribly hard to go, from changing from 0 to beginning day to end day to, a date window to do that sort of thing.
So you'd have to recode some of it wherever you're calling this specific function, because we need to add some like time arguments.
Yep, you could. I mean, it's this thing is all set up tools eyes. You could do a git, pip install this thing, and it will, install into, either in your local or global or as a developer directory, an egg file, either locally or globally. And so you could, basically do some kind of, I'm going to code up something new. You could call stuff like this, with translation, but basically call that method and, generate data with sort of the freedom, sort of that level of freedom that you want. But yeah. There is sort of a bit of contortion in here because matplotlib, although powerful, is not really been designed all that well. It's a pretty crappy library. It's just been powerful, and there are a bunch of scripts that are all on the web to tell you exactly what you need to do. One of the practical limitations of matplotlib is you can have, an axis, basically a plot object that you can't, farm off to separate threads. It sort of exists in one place, and it has no concept of being able to be even cloned. So some of the sort of hacking things that I've had to do is, okay, creating the geographic overlay is a costly process. But now what I want to do is, I have the data, like the visualization for day 5. When I want to do the visualization for day 6, 7, 10, all I do is basically change the color, the fill color of those geographic regions. And that's a relatively painless process on a, single, I guess you could call it a single task or a single thread. It also means that if I want to, multi-thread this out, farm it off onto a bunch of different processors using multiprocessing, each basically process has to, create the same geographic overlay, of, okay, here's the, bounding box, here's the actual polygons representing the counties, and all it does is it, farms it out onto, okay, processor 1 will look at days 5, 10, 15, 20, processor 2, 6, and so on and so forth. That's how it's farmed out. And then at the end, it's, collected together into, here's a bunch of images, and then, convert that all into an MP4 file, for instance. But there are workarounds, I should say.
Very cool. All right, well, we're almost 20 minutes past the hour. I think I'll rest the airtime from you. This is awesome, Tanim. I presume you're going to keep making updates to this?
It does it. It's going to keep doing it, I think around 12:30 in the morning, the 5th, right? Yep, there'll be a new update, or it'll start the update process, I should say.
Cool. All right, well, I'm going to steal sharing from you.
Sure.
Continue on with the evening. All right, well, let's get this going. There we go. There it is. Okay, so that was Tanim Islam again, back for a second time with SacPy. Thanks again, Tanim.
You're welcome.
Looking forward to any other updates you got. All right.
Well, you could just go to that URL, right? Look at Sacramento and see how it changes day to day.
Well, I'm sure you'll come up with some interesting ways to evolve the thing. So, all right. Well, next up is yours truly. My name's Woody Hooten. I've been running SacPy here since January last year. I worked on a project last year that was eventually a bot in Discord. It worked with a thing called CRM Dialer, and I was employed at a sales firm called Blue Sky Energy. So this is the Jarvis postmortem. I guess I made with a little bit of help from Robert, a translation from a PHP SDK to Python requests, and it was a little sales manager bot. All right, so running through just a top level view there, Solar World. It was a sales team, point and click stuff that had an API that needed some translation. And then I did some stress testing. I'll go over some of the tech that I used to do that, and some of the various like layers that I added to the system, and then how it went as we fine-tuned some of the things, and talk a little bit about the potential future for the thing, because as everyone knows, Jarvis is a very commonly known name, thanks to the Marvel hit Iron Man. But anyway, from the beginning, last year after COVID hit, I ended up joining a solar firm. Turns out solar firms are considered essential workers thanks to C10 contracting licenses in California. I joined these guys, Blue Sky Energy, headed up by Bernard Lewis. I was a solar sales and marketing firm. We'd do things like get a person's last 12 months of usage with PG&E or SMUD or something like that, put together a proposal based on their like Google Maps overview, and then some software that was out there that would do calculations based on the orientation of things and the tilt of the roof, the angle of incidence relative to, say, north-south, south-facing up here in the northern hemisphere, as it turns out, is ideal. And there were some calculations we had down to just like little back of the napkin calculations, but we'd give people these pretty decent proposals showing them how a system would work on their house relative to what we know about their past usage. So with the dialing team, we were more focused on going through large lists of names and numbers and trying to get conversations with people to talk to them about their new Lord and Savior, solar energy. We reviewed a number of tools. Eventually, we settled on this startup tool, a really small group out of New York. I think it's an implementation of a technology below it called Iris CRM, but basically these guys made a flavor of it that was dedicated to sales teams. So CRM stands for Client Relationship Manager, and it's a type of software that's used a lot for like customer support, community management, account management, that sort of thing. Just sort of keeping track of the details of a particular client and how they've been interacted with in the past by other people in the company, things like, things they've ordered from the company, existing subscriptions, everything you'd want to know when talking to a client and like paying client, hopefully would end up in this sort of software, a CRM. So you guys, I'm sure, have all heard of Salesforce. They have the giant ominous tower in San Francisco these days. They built their empire on top of keeping track of conversations that are being had with their customers. And then there is a type of software that's dedicated to telephony. It's called a dialer. There are a number of different types of dialers. There's power dialers, there are manual dialers, there are progressive dialers, there are predictive dialers, all with varying degrees of legality in terms of the automation being employed. The one called a predictive dialer, or maybe it's progressive. I think it's predictive. Well, what it'll do is it'll dial like 10 different numbers all at once. And then any one of them that gets a pickup, that'll be forwarded to someone dialing. I think that's been blocked or not blocked, but it's been illegal for quite some time. So we opted not to use that, but we used this thing called a power dialer. And so at some point we came across this software, very on the nose name, CRM dialer. And it's literally what we were looking for. And it was pretty nice because it was a usage based model and not just one of these like per seat models. But as you can see from the UI, pretty old school choices and some of the gradients and outlines in their divs. But, you know, long story short, the thing worked. Basic usage of the thing was, you know, point and click. You're waiting every single page load because this thing's running a website. Didn't have a, you know, native application that could be doing things a lot more efficiently in terms of, you know, just transitioning between contexts. So, you know, the thing had, you know, multiple seconds of lag time anytime you did anything. Mass actions in the interface were relatively limited. And then if you had enough people with the right permissions in the system, it was really easy to mess things up. And I'd say the cardinal sin in a sales dialing team is duplicate assignment of a lead. If you end up calling someone twice in a day, you can guarantee your company will never make a sale. So avoiding that was just like, you know, utmost importance. And if there were there were more than one person doling out leads, and even if it was just one person, it was entirely possible to accidentally double assign something. And, you know, just, you know, human error turned out created a whole bunch of negative human experiences. So basic GUI usage, GUI, that is a graphical user interface. For anyone who was wondering what that acronym stood for, you know, left something to be desired. Here's a little bit of what one could see when navigating an interface in a CRM. Every call, you'd have the option to say, make an appointment to follow up. You know, very often if you talk to someone who was interested, they were not ready to make a sale right then and there, and they'd ask you to call them back. So what do? Make an appointment. There's also things you need to do along the way. Sometimes you need to check out the usage that they have provided for you against PG&E. So maybe you add a task. There's also a number of ways that you can organize, set things for follow-up, set things for, you know, qualifying steps. As you can see here, in follow-up scheduled, there were a number of reasons. At the bottom, we added pandemic because turns out people were freaking out and still are. We probably have a bunch still in that folder. Yeah, operating through the system would have you navigating interfaces like this, where you're selecting a whole bunch of people all at once and trying to create call queues or trying to assign them to new people. It's not super great. As you can see, you know, that's 7 leads represented in, you know, not the greatest amount of space on a web server. So basically what it came down to, and this is what it looked like if you were power dialing. After you made one of these lists, you'd get this, oops, sorry. There we go. You'd get this soft phone and you could see the name of the person, the number that was dialing, and then the status on the call. If you look close at the bottom there, I don't know if you can see that, there's 2 buttons, one blue, one red. That the blue one allowed one to, if encountering a voicemail inbox, you could clear out a call by hitting that VM, the blue button. It says woodydvm.mp3, and it would play a recording of your little, hey, call me back voicemail. So we used the basic experience for, I think, maybe a month before I started digging into ways to finally do my favorite thing with Python, automating the boring stuff. I found that, well, when I was doing research for these dialer systems, I was looking for APIs that would allow me to work in Python, but unfortunately this one won out in terms of pricing. So they went forward with this one, but what they offered was a PHP SDK. And, you know, I had only had a little bit of experience in PHP, but I did have a good amount of experience in REST interfaces. And I realized that the way that they were putting together the requests, or rather the way they were sending their REST requests, am I saying that right? Yeah. Anyway, the way they were actuating it, I could break it down and move it into requests. So this is where Robert, aka Dr. Flask, came in. On Discord, we kind of tangled through this particular problem and figured out some things like, okay, you can see in the top area here, we've got a dictionary there called payload. And you can see at the bottom of that function, we're returning a GET request, and we're sending that payload as a value for like JSON. So we tangled through that for some time and figured that out. And turns out that was a pretty good way to go. But starting out there, you know, I was, after translating the thing, it was still merely touching their API in a way that was still needed to have some order to it, some level of scripting. So you can see here, I made a number of scripts. The top three there, scrub notes, wipe leads, assign leads, those are all kind of those are all called by the function before that or after that, refresh. You can see, also, I think scrub notes maybe goes through when you do wipe leads. I don't know. I'm sure it's a horrible form in terms of coding, but basically this was the regular cycle of managing any given dialer and their daily work in this dialing program. A person would come to you at the beginning of the day and say like, hey, I need a list of leads to dial. Could you send me some leads? More often than not, they had an existing set of leads, so that's why I called it refresh. But what it would go through, what it would do is it would go through and it would find their existing list, it would wipe them. And what wiping meant was, you know, look at every single one of them, check out what the updates were, look at their notes. Did they create an appointment? Was this set for follow-up in some way? Did the person that was on the list say like, hey, do not call me, please? You know, we took all that seriously, but seriously, human error is a real thing. And even if they got the note right, it was always possible that those things wouldn't get put in the right area just because, you know, things happen. But these scripts, it made it really easy to go through and just do things kind of perfectly every single time. So we'd wipe their leads, we'd assign them some new leads. As we were doing it, we weren't duplicating and all that stuff because, well, it's a lot easier to do it if you script it. I eventually got fed up with trying to actuate some of those tools that I made off of their PHP SDK and made it a really simple like command line interface. I would just type in the name and then it would go through and do all those things. So Nick would say, hey, I need more leads. And so I'd get on the interface and type in Nick, and then Nick would go through and do its thing. Refresh his leads, wipe his leads, assign new leads, scrub notes as he was going along. Just a moment. All right, so once I got this thing going, I eventually ran into the problem that one of our previous presenters, James Tejada, brought up, which was like, okay, great, that's working, but now you can never go on vacation and you can never quit, because we can't run this thing without you and how you have this currently set up. So the first thing that was like, there was a notable challenge, it would kind of stress test of the system was, I went on a trip to Carmel. And so I didn't want to disrupt the workflow of things, but I also didn't want to try to fall back on manual operation of the system. And so I found a way to move all of my scripts off my laptop onto my cell phone. So I don't know if anyone here is an iOS user. I think there are a number of command line options on Android as well, but being the iPhone user that I am, I ended up using this product called Pythonista. And what it allowed me to do is you know, basically the server itself was running off my iPhone. And so someone would text the internal chat channel and say like, what do I need new leads? And I'd go back through that same kind of UI, except on my phone. And so I had some fun with it. I got to the point where it was like voice control. But running a server off a cell phone, it's not great for keeping the cell phone battery alive, that's for sure. So the next step there was to finally move the user interface out of my hands and into the dialers themselves, and realize that Discord was actually kind of the way to do it. It was a relatively young team that we had, and my intuition was that many of them already would have had Discord, because I think a lot of them played video games. And I think it was like literally 9 out of 10. It was people like young or early 20s. 9 out of 10 already had Discord. So we use that as our company chat channel as opposed to Slack. And I dive into doing the actual Discord bot implementation, and maybe we can do that another time. But realistically, like, this is more about I guess using the Discord bot as like a UI, because using all the moderation channel or functions in Discord it's all well and good, but I think what it represents is this opportunity to kind of like anthropomorphize something that can take whatever level of granularity of text commands and even voice commands. Since making this one, I've worked with a couple of other people on making voice channel bots, but it was really interesting because I think maybe it was a combination of the name Jarvis, just because of what that meant to people in pop culture, but as well maybe the fact that this thing wasn't doing the work for you. What it was doing was getting work for you to do. It became an interesting feedback channel. So I started to try to zero in on how we could achieve the ends of like a successful dialing team. And what I realized that came down to was keeping people dialing and keeping the average number of daily dials going up, because basically it's a numbers game. You gotta get on the phone a whole bunch of different times. And so I started with some simple things, like anytime someone was trying to interact with the lead refresh program, I wanted to make certain it was going to do it as quickly as possible. And I think initially it was actually lagging behind human performance, but by the end of it, unfortunately, the server it was on that has the data from the logs is not accessible at the moment. I'm still working on booting that, but basically, like, it got to a point where it ended up replacing just like literally the worst, most boring work possible, lead management. and like far outperformed humans at the end. I think it's Peter Drucker says like what gets measured gets managed. There was something about self-service on getting leads and then having a running scoreboard that really pushed a lot of performance out of people. I can't stress enough. If you can put a number to it and just put it in front of people, don't tell them what's good or bad. Just show them they can move the number and fun things will happen. One of the things we did as we were going along was we added some leveling to the system. It started out, you come in at level 1 and you get 10 leads at a time. And that's pretty important early on. If you give someone 10 of something to do, way more palatable than trying to get someone to do 100 of something right away. It was interesting. Early on, we would say, okay, we want you to get 100 dials in a day. And so we'll give you 100 leads. And if you give someone 100 leads before they've really gotten any momentum, they'll dial like half of them or 70 or something like that. But if you give them 50, then they'll finish 50 and then come back, get 50 more, and then finish them and come back and get like 50 more. It's weird, sort of chunking them. Tanim says, have you ever seen the show Workaholics? Oh, I kind of think of that show. Yeah. Oh, dude. Yeah, there was some comedy, that's for sure. So this was never, I think, a presentation on quality processes. I think this is more just like wanted to talk a little bit about like a full stack experience. It was a fun one because like we were just trying to make things work. We were just trying to scrap things together, and yeah. All right. Well, we're dwindling in numbers here. I'll probably continue this talk in the future, but I just wanted to talk about that a little bit today, and I'll probably come back in a quarter or so and give you guys updates on where that's at. But any questions?
Well, what was the scoreboard that you showed a few slides ago? It had like ordered by like one before. Yeah, this one here. What are we seeing here? Like Leo, I guess, had 48, 57 dot like calls he made, or the
so
machine Jarvis gave him 48. Okay.
No, that's from June 1st to June 30th. Person got put in a lot of dials.
Wow.
Yeah, it was interesting to see how some of those the effects. Oh, yeah, Dan, I'll definitely get some code up. It's basically it's still something that I'd like to keep working on, and I'm going to be doing that with the Brazen Studios. I'm working on a number of conversations to get that going. We'll open source things as it goes along. I would have put the CRM dialer thing out there. I guess I can put it up later, but it's just such a it's such a non. Well, I don't know. It's not a super popular technology, but you know, whatever.
But wait, this is interesting because those I guess salespeople, right? They actually were on Discord, you know, asking Jarvis for leads, right? Was that the way they work? Cool.
Yeah. So we're gonna fine tune that a little bit. I'm gonna get the bot back up probably in the next few days, assuming we get the server space we're gonna get.
You could also have Jarvis give feedback to them, like "good job" or "you can do better."
Yeah, totally. Well, yeah. One of the things with Jarvis is he's kind of an IP nightmare. So it may be the last time we use that name. We'll figure it out. We talked a little bit about that yesterday.
I think Jeeves is fine, right? I mean, I think he's public domain right now.
Why is it an IP issue?
Disney.
This is the movie.
JARVIS, right?
Oh, with the dots.
The dots. You take the dots out, and you're kind of okay. Change the acronym, you're kind of okay.
Yeah, but there's
they'll still come after you regardless.
There's a bunch of videos on YouTube that all talk about the Jarvis software.
Oh yeah. Oh, and there's like a million Jarvis projects on like GitHub.
Yeah.
All that.
So
it was the least the least original part of the project was the name.
They either have to like get a flamethrower and attack everyone at the same time, or just let it go.
Yeah, or I think if you charge 0 for it and use it as a loss leader, maybe they can't come after you. I don't know.
Yeah, leases, right? Solar leases, isn't that how that works?
Oh well, as far as like a CRM goes or a power dialer goes, it shouldn't much matter what the content is you're going after. But as far as that particular project, yeah, that was solar. Cool. Well, yeah, I'll probably be spending a good amount of time productizing that as the year goes along. But
so Tanim, your use of pickle, I thought that was really interesting, because it's something you read about, but you don't really think of that as being like a database.
Yeah, I mean, I just wanted something quick and dirty. It's very fragile. I mean, if I change the code base, there's like no guarantee that the updated code base that I've updated with, say, import lib could read it. Although the data structures that I have there, I think it's pretty robust because they're dictionaries. The keys are, I think, strings, and the values are pandas data frames. That's the most complicated thing there, which might work. I don't know how unpickling works if the substructure is a pandas data frame. But your mileage may vary. I've heard of technologies like BSON that are designed to be a lot more robust and portable than just pickling and unpickling.
What's it called again?
BSON. It's like binary JSON. I've heard of stuff like that. There's you could even future proof it with HDF5, but it can get unwieldy to do that. I've only used HDF5 when the underlying things inside it are like gridded data or scatter data, either like a bunch of rows, which is basically pandas data frame, or something like a NumPy, multi-dimensional NumPy array. But when you do, at least
it looks like you solved a bunch of really interesting problems on the road to completing this project, and there's lots of interesting little side trips for how you do a lot of the pieces of it.
It helps to have a supercomputer. And there was an older way. I quickly abandoned it, which was basically trying to be quote unquote clever and using thread pool executors. And it would just choke a single node. It would just be like, okay, if I wanted to create like 4 movies, even sequentially on a single node, it would run out of memory. It was just conceptually the design, the parallelism, the highest level parallelism is pretty straightforward. It's like you basically chunk the jobs among the 9 different nodes, and each job, it's like 26 times 4 or 26 times 5 is round robin chunked among 9 or however many nodes that you have. And it's just, okay, does that job, okay, then it goes to the next one. So there's no say, memory exhaustion issue, and sort of because it's batchable, it's sort of embarrassingly parallel at the highest level. It's not like any any task, any one of those tasks depends on the status of a previous task. So
Yeah.
it worked out okay in the end. You know, you could scale it up to all 300 MSAs, 50 states. um, you know, also Puerto Rico. But you know, maybe I'll get a talking to at that point. Then the data set would probably be like 6 or 7 gigabytes in size, and so, or
Right.
maybe 20 or 30. And then it becomes, well, what the hell am I doing here? But yeah,
Yeah.
it's presumably, you know, I threw out buzzwords, you know, in one of the last slides saying what I've developed is something that, you know, uses MPI. But maybe a more portable solution would be to use some kind of thing like Kubernetes or Docker. And I'm throwing those buzzwords out because I've never used them, and I don't even know if my application makes sense, or like maybe I'm just missing the context altogether. But I'm thinking sort of a cloud of machines that got spun up and does a part of, you know, the whole set of stuff, and then, you know, some foreman node that collects all the data and then deploys it, you know, to that, you know, directory. There's no particular reason why it has to be, you know, using a supercomputer with MPI to chunk out the jobs. It could be some other way to do it. It's just I don't know how.
Mm-hmm. Okay. It was an interesting talk.
Thank
So
you.
yeah. All right. Well, night, Woody.
Yeah, thanks for coming, everyone, and thanks again, Tanim.
You're welcome.
Anybody else want to speak? I'd say take a screenshot real quick. Otherwise, find us in the Slack or Discord channels. Get a mailing list too, but I don't know. We need the chat channels more than anything at this point. Yeah. Before we go, anyone else in the remaining 6 of us want to throw anything on the YouTube? Any shout outs?
Well, I know we've talked about this. I'm sort of a hard ass now on documentation. And so,
yeah,
not the next one, but, you know, maybe the one in 2 or 3 months, I want to, you know, flesh out real world use cases of, you know, creating useful, practical Sphinx documentation without killing yourself. Because it's a really powerful tool. It's got a bit of a learning curve, but once you've got sort of the 5 to 10% of the all the elements in there, you can get 95% of the work done. Like what I showed, you know, in my talk was, you know, Sphinx documented, read the doc style page, you know, documentation page for COVID-19 stats, and you know, the coding to get that done wasn't really complicated at all. It is a lot of writing, and it's a lot of thought to, you know, figure out the logic of, you know, how everything fits together. But that was really the hardest part.
very cool.
Awesome.
All right, well, thanks everyone. See you guys all in a month.